Okay, I'm starting with four chemicals: water, paper saturated in water, iso-2-propanol, methanol, and one in oil. Okay, so now I'm taking out the water. I'm taking out the 2-propanol, the methanol, putting them down on the table, and the oil. Okay, the paper's soaked in oil. And we're just going to take a look at them. Here we go. So this first one here is water at about 20 degrees. Next one is this is at 21 degrees, and we're getting areas that are like down to 18. Okay, that's the 2-propanol. This is the methanol. It's at 19. And this is the oil, 21. And we're just gonna keep on scanning these, keep them at the same height, look at what's happening. Again, look around, 17. Propanol is pretty uneven. Looks like the edges, might be seeing some evaporation there first. It's around 21, and let's go to the water. It's about 20 degrees. Okay, so we're just gonna keep on doing this for about 7 minutes and just observe what happens. Okay, so I think there's definitely a difference between, it's about a degree difference between the methanol and the propanol. The oil, probably the highest. Okay, just trying to keep it nice and steady. Looking at different areas there. So we're just going to keep doing this for about 7 minutes. Just look for any changes. And again, I'm trying to keep this as steady as I can. Keep it above the same thing. Got about 5 more minutes. So the water, after about 2 minutes, is 22. The 2-propanol, it's like down to 21. Although there are areas that are colder. Okay, certainly. Methanol, it's down to 19, 18. Okay, so it's a little uneven, which is kind of cool. And then the oil, ain't doing nothing for the oil. It's about 22 degrees. Okay, so what does that blue color mean? What's happening? All right. Just going for about 7 minutes. Okay, so we're just trying to, now the propanol, the reason this is popping up is that it's kind of popping up, it's starting to curl up a bit. So the air is getting underneath the top and the bottom, which is why it's evaporating faster. That's kind of neat. Okay. And same thing with the water. Just trying to keep it down there. So the interesting thing is the propanol, when the ends here pop up a little bit, air gets underneath, faster evaporation, gets colder quicker. Imagine that. It's like a bridge in the wintertime, right? Let's go. Ooh, methanol's really dipped down a little bit there. Going back to our oil, it's at 24 degrees. So this demonstrates the evaporation process. As liquids go to a gas, it takes energy. The positions get farther apart, usually an increase in potential energy, maybe kinetic energy there. And the energy has to come from somewhere, so it steals it from wherever it's at. It gets colder. So things get colder faster and evaporates faster. What does that say about the intermolecular forces? Okay. Got about 3 more minutes. Let's keep it nice and steady. So 23 for oil. Methanol's down to 19. propanol has different areas. Part of it's 15, and again, that's where it kind of popped up in 22, so it's down there. Maybe not as low as methanol. The water, less than oil, more than the other ones. Okay, so we'll continue for about 2 more minutes. And then typically what we'll do is we might want to compare this with class data as well. Because if you do it once, I always say it's an anomaly. But if you do it more than once, then we can start calling it science. Okay, so again, 24 for the oil, 20-ish for the methanol, about 21 for the propanol, water, 22-ish. There's a slight difference, but we can detect it. All right. Yeah, 19 for the methanol. Again, the oil, the messy one, still at 24. Interesting. There we go. 19. There's the propanol, 21. Water's about 22. All right. Okay, so we got about 30 seconds, and then we're going to hit end. Go. So, our little experiment's over. We're going to call it quits now.